Hello friends, this video on alcohol, phenols and ethers part 2 is brought to you by examfear.com. No more fear from exam. So out of all these type of hydrides we have discussed, monohydride, bihydride, trihydride. The monohydrides are little important because we have further classification of monohydride alcohols. So based on the hybridization of the carbon to which hydroxyl group is attached. For example, I told right in all the alcohol will have something like this COH, where OH will be attached to one carbon. So based on the hybridization of this carbon, we have different types of monohydride alcohols. So if this carbon is sp3 hybridized, then we have primary, secondary and tertiary alcohol, or we have allylic alcohol and benzylic alcohol. We'll discuss about these in the next few slides. If this carbon is sp2 hybridized carbon, then we have vinylic alcohol and phenols. So we'll discuss about, if you see now here in this definitions, phenol is nothing but a type of alcohol, right? So there are two different definitions actually. In one, according to one definition, the phenol is a type of alcohol, and the other one says that alcohol is only for aliphatic and phenol is for aromatic. But you should not be confused, it doesn't matter. Right? So let's start with the primary, secondary and tertiary alcohol. So as I told, we have discussed this. Primary means the carbon which I am talking about is attached to 0 or one other carbon. Secondary means the carbon which I am talking about is attached to 2 carbons. Tertiary means 3 carbons. So if you see, this is the carbon I am talking about. So maybe this is a hydrogen here. So there are 2 possible combinations here. Either it is CH3OH or CH3CH2OH. So in both this case, in this case, this carbon is attached to 0 other carbon. In this case, this carbon is attached to, let me write it, 1 other carbon, right? This is my star carbon. Correct? So always the star carbon is nothing but the carbon to which OH group is attached. Correct? This is my primary alcohol. This is my secondary alcohol because there are 2 R groups here. Each of this R group will have some carbon. Here also this tertiary, if you see, R1, R2, R3. Correct? This is tertiary because this carbon is attached to 3 other carbons. So we have discussed this in the past few chapters, so I'll not stress on these. And they are generally liquid. Then we have allylic. So allylic, if you see, here the star carbon which I have, so I'll just first draw the star carbon here, right? The carbon which is attached to OH or my star carbon. All these star carbons is attached to a carbon that is double bonded. Star carbon is not double bonded. Please note, star carbon is not double bonded. Star carbon is attached to a carbon that is double bonded. You see, this is my star carbon, that is sp3 hybridized, if you see, and this carbon is attached to a carbon, and that carbon is a double bond. That's called allylic carbon. So if you see, this carbon is sp3. I can show you how. Correct. So in this carbon, if you see 1, 2, 3, 4 bonds, so it is sp3 hybridized. This also, if you see 1, 2, 3, 4 bond, sp3 hybridized, 1, 2, 3, 4, sp3 hybridized. And these are also generally liquid. And here also, if you see, you can further classify as 1 degree, 2 degree or 3 degree. So if you see, this is the star carbon, this is attached to only 1 carbon, so it is 1 degree. This is the star carbon, this is attached to 2 carbon, this is 2 degree. This is my star carbon attached to 3 other carbons, so it is 3 degree. Correct? So I can further classify allylic alcohols into 1 degree, 2 degree and 3 degree alcohols. Let's start with benzylic, and that is also sp3 hybridized. So if you see, this is my star carbon because it is attached to OH. Here this is my star carbon and this is my star carbon. If you see, this star carbon is not part of benzene ring. So don't get confused. This is not sp2, this is sp3, this is normal alcohol. And now if you see, this star carbon is attached to a benzene ring. So this is called benzylic alcohol, right? Where my star carbon is attached to benzene ring or aromatic ring. And they are also generally solids. Here also you can classify by first degree. This carbon is attached to only one carbon. This is a carbon here, 1 degree. This carbon is attached to one carbon, 2 carbon. It's 2 degree. This carbon is attached to 1, 2 and 3 carbon. So it is 3. Correct. So you can further classify the benzylic carbon also, benzylic alcohol also has 1 degree, 2 degree or 3 degree alcohol. The next is vinylic alcohol. Here it is sp2 hybridized and the star carbon itself is double bonded. So if you see, this is my OH bond, this is my star carbon, and if you see, this is double bonded. So you saw in allylic alcohol, the star carbon is attached to a double bond carbon. The star carbon itself was not double bonded, but in the vinylic alcohol, the star carbon itself is double bonded. Correct? So if you see, the OH bond, the star carbon is double bond. And then I have phenol. So phenol, if you see, the star carbon itself is part of the benzene ring. This is my star carbon here. The star carbon itself is part of the benzene ring. Correct? So these are my phenols. This is my phenol, this is my phenol. And if you see here, this is sp2 actually. Why it is sp3? It is sp2 hybridized. And the other one which we have just discussed, vinylic, was also sp2 hybridized. I can show you why it is sp2 hybridized. If you see this carbon here, there is 1, 2 and 3. See, double bond also you have to count only once. 1, 2, 3, so sp2. This also a point if you see 1, 2 and 3, so it is sp2 hybridized. Correct. Now we'll discuss ethers. So ethers are, as I told, formed when the hydrogen is replaced by alkoxy or aryloxy group, that is OR or OER. So ethers are further classified as simple or symmetrical ethers and mixed or unsymmetrical ethers. So in case of simple or symmetrical ethers, the alkyl or the aryl groups attached are same. For example, if you see C2H5, OC2H5. So this part and this part is same. Or you can have CH3, OCH3. So if you see, both parts are same. Or you can have a phenol here, and then you can have a phenol here. Right? So they are symmetrical ethers because this side is same. And then you have unsymmetrical ethers where these two sides are not same. For example, C2H5, OCH3. Both are different. Or you can have a phenol here, and then you can have CH3 here. So if you see, this side and this side are not same. Correct? So if both sides are same, it is called symmetrical ethers. If both sides are not same, it is called unsymmetrical ether. And they are also generally liquid. So let's take one numerical here, and we have to classify each of these based on whether it is a allyl, benzyl or vinyl alcohols. Right? We discussed all these. So if you see this guy, so this is my star carbon, and this star carbon is attached to a carbon that is double bond. So it is what? I'll give you 2 minutes to think. This is either allylic or vinylic. Think again, which is this, allylic or vinylic? See, the star carbon is not double bond. It is attached to a double bond. Correct? So one memory tip to understand is this, you know, allies means friends, right? So we say the countries has allies, the countries has friends, right? So India is friend with, let's suppose, China. So India and China is ally. So that way. So if you see here, this is the star carbon and his friend is a double bond carbon, right? So his friend is rich, right? So here we can, the moment you think of this, star carbon is not double bonded, star carbon friend is double bond. So star carbon friend means ally, right? And with that you can say that it is allylic. Just a memory tip to understand this. Star carbon is not double bonded, star carbon's friend is double bonded, right? Star carbon's friend is double bonded. So star carbon friend means ally. So it is allylic alcohol. Same thing here. This is my star carbon. Star carbon is not double bonded. Star carbon's friend is double bonded. So it is also allylic alcohol. So this and this here also, if you see, this is my star carbon because OH is attached to it. And star carbon is not double bonded, but star carbon's friend is double bonded. Friend is ally. So it is also allylic alcohol. Correct. Now if you see, this alcohol is attached to only one carbon, so it is 1 degree. This alcohol is attached to 2 carbon, it is 2 degree. This alcohol is attached to 3 carbon, it is 3 degree. Correct. Let's say this. So this is my OH group attached to this carbon. This is my star carbon, right? So star carbon itself is double bonded. So it has to be vinylic alcohol. If you want a memory tip for this, star carbon itself is double bond. The star carbon is the winner. Star carbon is winner. So it is vinylic alcohol. Just a memory tip. Please note, this was allylic because the star carbon was not double bonded. Star carbon was not the winner. Star carbon's friend, that is ally, was the winner. So it is allylic alcohol. Here the star carbon itself is the winner. So it is vinylic alcohol. Correct. And this is my star carbon here. And this is my star carbon. The star carbon is part of aromatic ring. Star carbon is part of aromatic ring. Straight away it is phenol. Star carbon is part of aromatic ring. It is phenol. Here this is my star carbon. Star carbon is not part of aromatic ring, but star carbon is attached to a benzene ring, right? Star carbon attached to a benzene ring, so it is benzylic. This is my star carbon. Star carbon is attached to benzene ring, so it is also benzylic. Star carbon is this. Star carbon is attached to a benzene ring, so it is also benzylic. This star carbon is attached to only one carbon, so it is 1 degree benzylic. This carbon is attached to 2 carbon, so it is 2 degree benzylic. This star carbon is attached to 3 carbon, so it is 3 degree benzylic. Let's talk about these guys. This is ROR, that is, it is ethers. Both are same, so it is symmetrical ethers. These two are not same, so it is unsymmetrical. Correct? This is by symmetrical ether, this is unsymmetrical ether. So let's take one numerical, easy numerical, where it classifies alcohol as primary, secondary or tertiary. This is my OH, this is my star carbon attached to 1 carbon only. So it is 1 degree, this is primary. This is my star carbon. Star carbon's friend is powerful, so it is ally, that is allylic. But that is not the question. Question is whether it is 1 degree or 2 degree. This carbon is attached to only 1 carbon, so it is 1 degree. This is my star carbon attached to OH. Only attached to only 1 carbon, so it is also 1 degree. This is again my star carbon attached to OH, and this is attached to 2 carbon, right? 1 and 2 carbon. There is also carbon here. It is 2 degree. This is my star carbon here. Sorry, this is not a star carbon. This is OH, so this is my star carbon, and this star carbon is attached to 1 and 2 carbon, so it is 2 degree. Where is the OH? This is the OH. This is my star carbon. This star carbon is attached to 1, 2, and 3 carbon, so it is 3. Just to repeat, this carbon's friend is powerful. Friend is ally, so it is allylic. And this is also, this carbon's friend is powerful, so it is allylic. This carbon is attached to benzene, so it is benzylic. Here this carbon is not attached to benzene, so it is different. That's all. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.